Hey guys, so this is our next video. We're still in World 2. This is going to be Level 3. It's all going to be all about parallel lines cut by a transversal. Our LEQ for this lesson is how can you find the measures of all the angles formed when two parallel lines are cut by a transversal? Right, so let's go ahead and get started. Let's start with some definitions. You might already know this, but parallel lines are two or more lines that never intersect or touch like the ones we show here. We can intersect these parallel lines with another line, which we would call a transversal, like the line shown in white. Transversals can only intersect each parallel line once, meaning that the line must be straight. So a transversal is a line that intersects two or more other lines, and it must be a straight line. We can go ahead and label all of the angles formed when we intersect the two parallel lines by the transversal, and now we can identify some different angle relationships. We should remember that vertical angles are formed when two lines intersect and that they share a vertex but not a side. You should also recall that vertical angles are congruent or equal. In this diagram, we have four pairs of congruent angles. They would be angles 1 and 3, angles 2 and 4, angles 5 and 7, as well as angles 6 and 8. So in this diagram, we know those opposite angles are equal. We can determine a lot about the measures of the 8 angles shown here just by knowing the measure of one of the angles. In this figure above, let's assume that the measure of angle 1 is 70 degrees. From the previous slide, we know that angle 1 is vertical with angle 3, so we know that they must be equal. So that would also be 70 degrees. From this information, there are many ways that we can find the other measures around that parallel line. The easiest way for us to see is to notice that each of these angles are supplementary. So angle 2 is going to be supplementary with 70, and angle 4, so angle 2 and 70 are supplementary, angles 4 and that 70 are supplementary. So from that, we should be able to take 180 minus 70 and know that each of those angles would be 110 degrees. We also know from the last slide that angles 2 and 4 are vertical, so we can confirm that they're both 110 because they are vertical angles, making that they are equal. To check that we have the correct answer, we can add all four of these angles up. Since we know that all of the angles that meet around a point must equal 360, we can take 70 plus 110 plus 70 plus 110, and we would verify that we have 360 degrees. We now need to determine that the measures around, or the measures of the angles around the second set of parallel lines. Okay, so we're going to take and cut our diagram in half, just like this. And notice now how these look similar. Okay? And if I were to cut it in half, I have these two shapes. They look similar. If I were to take now and lay these two diagrams on top of each other, like this, we know that they are in fact the same exact diagram. Since we cut the parallel lines with a transversal, the angles around both of the lines are going to be the same. Let's look at the combined diagram again so that we can figure out some of our angles. So here in the upper left, I have the diagram from the last slide where I put both of them on top of each other. And in the bottom right, I have that combined diagram that we had cut in half. Notice in our upper left-hand picture that angle 5 is in the same position as the 70-degree angle, so we can identify that angle 5 is also 70 degrees. Angle 5 and angle 7 are called corresponding angles because they are in the same position around each parallel line. We can use this same relationship for all of the other angles to determine that angle 6 is 110, angle 7 is 70, and angle 8 is 110 degrees. Okay, so now that we know how to find the angles around two parallel lines cut by a transversal when we're given one angle, let's define all the different angle relationships that are formed in these situations. We've already talked about the first relationship, which is corresponding angles, or angles that are in the same location around two parallel lines cut by the same transversal. In our diagram, the corresponding angles are angles 1 and 5, angles 2 and 6, angles 3 and 7, as well as angles 4 and 8. We can also determine from this that corresponding angles are congruent, meaning they are equal in measure. Let's take a look at some other pairs of angles that are congruent, but not around the same parallel lines. We know that angles 1 and 5 are corresponding and equal, so let's start with this. Earlier, we said that angle 5 and angle 7 are vertical, meaning that they are also equal. So now we have that angle 1 equals angle 5, and angle 5 equals angle 7. Through the mathematical property of transitivity, we could say that angle 1 is equal to angle 7 by taking out the middleman of angle 5. Angle 1 and angle 7 share a special relationship as alternate exterior angles because they are on alternate or opposite sides of the transversal and are exterior or outside of the parallel lines. From our reasoning, we know that alternate exterior angles are also congruent or equal. In this diagram, our alternate exterior angle pairs are angles 1 and 7 and angles 2 and 8, as both of these pairs are on opposite sides of the transversal and outside the parallel lines. We're now going to apply some similar reasoning to take a look at angle 4. We know that angle 4 is corresponding to angle 8, so they are equal. Then we know that angle 8 is vertical with angle 6, so they must also be equal. Once again, by the mathematical property of transitivity, we know that angles 4 and 6 are also equal by taking out the middleman of angle 8. These angles are called alternate interior angles, as they are on opposite sides of the transversal and inside the parallel lines. Again, through our reasoning that alternate interior angles are congruent or equal in measure. The other pair of alternate interior angles in our figure are 3 and 5. So 3 and 5 and 4 and 6 are alternate interior angles. There are two more angle relationships that we need to take a look at. We've already looked at angles that are on the same side of the transversal and in the same location, which we called corresponding angles. We looked at angles that are on opposite sides of the transversal and outside parallel lines, called alternate exterior angles. And we looked at angles that are on opposite sides of the transversal but inside the parallel lines, called alternate interior angles. The only pairs of angles that we have not yet looked at are the angles that are on the same side of the transversal, where both angles are either inside or outside the parallel lines. An example of this would be angles 1 and 8. Notice that both of these angles are on the left side, the same side of the transversal, and both are exterior or outside of the parallel lines. Because of this, we simply call them same side exterior angles, because they are on the same side of the transversal and outside the parallel lines. Let's see what we can determine about these angles. We know that angle 1 corresponds with angle 5 and is therefore equal. We also know that angle 5 and angle 8, when added together, make a straight angle, meaning that they are supplementary. Therefore, we know that since angle 1 is equal to angle 5 and angle 5 plus angle 8 equals 180, we can determine that angle 1 plus angle 8 would equal 180 by transitivity, and therefore angles 1 and angles 8 are supplementary. So same side exterior angles are supplementary angles. Our two pairs of same side exterior angles in this diagram are angles 1 and 8, as well as angles 2 and 7. If we talked about same side exterior, the only other thing we have to talk about is the same side interior angles. These are going to be angles that are on the same side of the transversal and inside of the parallel lines. An example here would be angles 3 and 6. So let's go ahead and see what we know about these. Following the same logic that we just went through, which we can see on the screen here, angles 3 and 7 are corresponding, angles 7 and 6 are supplementary. Therefore, if I take out the middleman of angle 7, I see that angle 3 and angle 6 are supplementary. Therefore, we've determined that same side interior angles are also supplementary. And our two pairs of same side interior angles in this diagram are angles 3 and 6, as well as angles 4 and 5. I know this is a lot of vocabulary, so let's go ahead and summarize what we've talked about. There are 5 new vocabulary terms that you'll be responsible for from this video. Corresponding angles are two angles that are in the same location around two parallel lines cut by the same transversal, and we know that corresponding angles are congruent. Alternate interior angles are two angles that are on opposite sides of the transversal and outside the parallel lines, alternate meaning opposite, exterior meaning outside. We know that these angle pairs are congruent. Alternate interior angles would be two angles that are on the opposite sides of a transversal, but inside the parallel lines. Once again, these angle pairs are congruent. Our last two definitions were same side exterior angles, which are angles that are on the same side of a transversal and outside of two parallel lines, and same side interior angles, which are angles that are on the same side of a transversal and inside of two parallel lines. And we know that both same side exterior and same side interior angles are supplementary. So when you come back to class, you should now be able to, if I give you a diagram, you would be able to use the information from this video to answer the LEQ of finding the measures of all the other angles that are formed, and you would have many different ways to do that. We're going to take a look at some simple examples in class, and we're going to take a look at how we can use this information to solve some more difficult examples or some things where we're putting different shapes together and we need to use properties of parallel lines in order to solve them.